So SVM is also known as the large margin classifier. So in fact, support vector machine is all about finding the maximum margin classifier. Classifier is a generic name. It is actually mathematically it is called as hyperplane. So hyperplane is a kind of, you can imagine in a two-dimensional plane it's a kind of line. In a three-dimensional system it's a plane. So basically finding that classifier or finding that hyperplane that separates two classes, class 1 from class 2. So what SVM does is it makes use of the nearest training examples or training data points in that objective space. Based on them, SVM algorithm finds out that hyperplane that separates these two classes into two different, classifies these two different classes. Each data point is considered as a p-dimensional vector. Each data point, if there are p variables, then each data point is a p-dimensional vector. So what SVM does is it uses vector algebra and mathematical optimization to find that optimal classifier or the optimal hyperplane that has the maximum margin, and we have already seen the one with the maximum margin generalizes better. So here is the basic algorithm intuition of SVM. So if our data set is really linearly separable, then we can definitely always find a classifier that classifies the overall objective space. On the one side of the classifier everything will be labeled as positive, on the other side will be labeled as negative or class 1 or class 2. So this hyperplane is nothing but a simple, like in a two-dimensional space it's a simple line equation, or it's just w1x1 plus w2x2 plus b, or we can just rewrite it as w transpose x plus b. Given that hyperplane, we can always calculate the distance between that particular line or a hyperplane and the each point or a vector. Each point is considered as a vector, n-dimensional vector. So some points are on the edge and that are close to hyperplane. There are so many points in this objective space. These are far away from the hyperplane. These are also far away, but some points are close to edge, close to the hyperplane. That is like those which are on the edge of the objective space. They are close to the hyperplane. And distance this between these points like A, B and C, like this distance is known as the margin of the classifier. So all these data points on the edge or all these vectors on the edge constitutes to the margin of this particular classifier. So these vectors A, B, C are called as support vectors because they are the ones that are helping us to find out the maximum margin classifier. So based on these points or support vectors, hyperplane with maximum margin is determined or calculated. That is what the SVM algorithm all about. Now that is the overall philosophy of the SVM algorithm. Given these points, we can always find a plane. So what exactly is the math behind the SVM algorithm? We need a bit of vector algebra and some other calculus numerical techniques to understand this whole math behind SVM, but from at least we can take it for granted that given these points on the edge, and we can always find a plane that is right in the middle or that has the maximum margin. Or if we really want to get deep into this, then you can go through each step by step. Finally we can solve a particular optimization equation that will give us W and B that will indeed constitute to the maximum margin hyperplane. So how does the output of SVM look like? What is the result of SVM? SVM is all about fitting a hyperplane that has maximum margin that separates the two classes with a maximum wider margin depending on the support vectors that are on the edge of the objective space or that are near to that hyperplane. So SVM doesn't output any probability or anything. It directly gives us which class the new data point belongs to. For a new data point, let's say xk, we calculate that particular value w transpose into xk plus b. If that value is positive, then the prediction is +1 or -1. So at the end of SVM, we get as a result, we get just the class of that particular new data point. Will not get any probability as a result. There are multiple packages available in R to build an SVM model. The package that we are going to use is E1071. That is one of the most widely used package. Within E1071, there is a specific function called SVM. That is what we are going to use. E1071 has several other functions inside it. There are various options within SVM function to customize and to build the model or to make the data training, to customize the data training. But here we are going to see some of the basic options to create a basic SVM model. So we'll take one example of transaction data itself, just to get an idea on how to build an SVM, how SVM can predict, and then we also will try to see how to draw the SVM diagram where we can see the positive classes, negative classes, and the maximum margin classifier as well. Here is our data set, transactional data. So we have already seen the transaction sample data. This is our data set, and we'll attach E1071 library, and this is the transactions data, and we'll build an SVM model. We just give what is the dependent variable and what are the independent variable and the dataset name, and then we can see the summary of SVM. There are number of support vectors 8, kernel is radial, we'll talk about kernel later, and it's a classification type because the output is 10 categorical. Then we'll try to draw what exactly is our data. Our data set looks like this, so we are expecting SVM to categorize this as class 1 and class 2. So let us plot the SVM model. SVM has its own inbuilt way of drawing the graph, so this is how SVM is drawn, and anything on the pink color is 1, classified as 1, everything on this side is classified as 0. Now if there is a new data point where transaction amount is this much and transaction per week is 15, whether that class is 1 or 0, we need to use the SVM model that we just built and use the predict function and see what is the value of predicted. So the predicted value is 1. So the first value of prediction is 1. And then similarly, if the transaction amount is 2000 and transaction per week is 4, whether it is predicted as 1 or 0, so the predicted value is 0. So this is just an index, first one, but this is the actual predicted value. Since we know SVM is going to predict as 1, 0 classes only, so the output will be always it will be categorical 1, 0 types. Let's build an SVM model on the overall data. These are the overall transactions. This is slightly bigger data set compared to earlier one, so we can see number of rows and columns in this data set. There are as many as 45,000 rows and 4 columns, and then we'll build an SVM model type equal to C, that means classification model. Out of 45,000 observations, number of support vectors are 44. So support vectors, the vectors on the edge that will determine the hyperplane with maximum margin, there are 44, and we can plot SVM, and the support vectors can be seen in marked as into or X mark. So this is the SVM. These are all the data points, and the support vectors are marked, or the vectors on the edges are marked as X. So there are 44 of them. So that is how we build the support vector machine model and use it for prediction